folks, and welcome to Maths and Physics for You. Today we are going to show you how to find the model for the Ferris wheel rotation as a sine function, this time as a sine function. In the previous video we saw how to find it as a cosine function, so you can refer to that as well if needed. But in most cases, in exams, in assignments, they ask you also to find the sine function because it is more involved. So let's see how we get it. Okay, it's the same example. The Ferris wheel that rotates and completes a rotation in 4 minutes. That is, the period T is 4 minutes. As we can see here, period T equals 4 minutes. The radius of the Ferris wheel is 25 meters. The radius is 25 meters, and it's 5 meters above the ground level. That is, the lowest point here is 5 meters above the ground level. Okay, so we are required to find the sine function. Okay, as you can see here from this rotation, the period T is 4 minutes, so we can graph it, the height versus the time in minutes we have taken. So we have 1, 2, 3, 4 minutes for complete rotation. This is the period. Okay, so after at the start, when T is 0, the height is 5 meters. So you are sitting here on the seat at this level. Okay, that's where you are. Okay, when it starts moving, after 1 minute, your height now is 25 meters, the radius plus 5 meters. That is, you are at this point. After 1 minute, you are at this point, which is 1:30. That is, it's x-axis, the time is 1, and the height is 30. Okay, you keep going up. This is the highest point. Alright, this is the highest point, corresponds to this. That is, after 2 minutes, your height is h equals 55, as we can see here, because it's the radius, twice the radius, 50 plus 5. So that gives you 55. So this point is 2 and 55. And it continues like that, so the height decreases now back to 30, as it was here, after 3 minutes. So that's point. As you can see, this is 3:30. Alright? And finally it comes back to the starting point, where h is 5 meters, that's h 5 meters. So this is, again, 4 minutes and 5 meters. Okay, so this is the graph. Let's see how we find the sine equation. As we said, the height is given by this formula. This is the general formula. That is A sine B into the variable t, that is time in this case, minus C, that is sine of all this, plus D, the constant. Okay. Now, A is the amplitude. What is A? A is the amplitude of rotation. That is halfway between the maximum and the minimum. The maximum is 55 and the minimum is 5. That is, the difference is 50 divided by 2, 25. That is this distance. This is A. Alright, so we can say this is A. A is 25, so substitute here. H is 25. Sine. What is B? B is the frequency of rotation, actually. B in physics is the frequency of rotation, which is given by this formula. B equals to 2 pi over T, the period. If we sub here the values, we know T is 4, as is given complete rotation in 4 minutes. So if you are given different equation, of course you have to substitute different values. All you have to do is to plug in the new numbers. So that's over 4. Simplify, that gives you pi over 2. Okay, so we know now these constants. B is pi over 2, A is 25. So we put here pi over 2. Okay, T. Okay, we want to find C now. We want to find C. Okay, let's see what is C. C is a constant that has to do with the horizontal shift. That has to do with the horizontal shift. Okay, sometimes they call it phase difference. Okay, so it could be minus or plus. It depends upon the movement. If it is to the left or to the right, that is the graph of the sine function. What we are referring to is comparing this to the original basic sine function. As you know, the sine function, if we can quickly put it here, this is the period. Normally, if you have y equals sine x, okay, this is a1 and 1. Okay, if this is the period, half period, quarter, 3 quarters, goes like that. All right. So it goes like this. As you can see, this is y equals sine x. This is the basic function. Okay. So where it starts at the origin, where this is x and this is y. Here we start static. This is a sine function. See, this is the shape, original shape. So it's not static. This one starts at the origin. But here, instead, if you compare these shapes, it starts here at this point. It starts at that point, as if it has shifted to the right. See this? This is from here, comparable, see? Comparable with the basic function. So this means as if this point has moved from the 0, 0, from this point, from the origin here, to that point. It's x, it has moved to the right by 1 unit. See, this is the horizontal shift. See, this point is actually that. This is the original for the basic function. So this has moved to the right by 1 unit. I draw the arrow here to show you how this moved 1 unit, and up by 30 units. So 130. So C is 1. C is 1. Is the horizontal shift. Is the horizontal shift of the starting point. This one of the basic function. Okay, when we compare it to the basic function. So it's this figure. This figure, the horizontal. This is the horizontal. Alright, so this is 1 unit. That's why this is 1. So C is 1, and we put negative because if it moves to the right, we put negative. If it moves to the right, we put negative. If the shift was to this side, if it started from here, then we put plus. So remember this. If the movement or the shift to the right, we write minus. If it is to the left, then we write plus. That's why, because we consider that this is the norm, the standard minus. So see here, in this case, is plus 1. So that this makes it minus 1. The whole thing is minus. In some books, they say plus C. If it is plus C, then they say minus, C is minus 1. But this is easier to put it this way. All right? Okay, let's keep going. And plus D is the height, the vertical shift. Now this was the horizontal shift. This is the horizontal shift. This is the vertical shift up. Okay? So how much is that? 30. Yeah, very good. This is 30. This is the movement of this point, of the origin to that point. Okay, so 30. So D is 30. Simple. So this is the equation. So now we got the equation by just understanding what's going on and plugging the numbers, substituting the numbers in this simple formula. So that we get h equals now 25, the amplitude, sine pi over 2 from the period and frequency, into t minus 1, the horizontal shift to the right, plus 30, the vertical shift up. Okay, so this is the equation. But to satisfy yourself, to confirm it, we do checking. So to see, we see check h, the height, when the time is 0. We expect when the time is 0, the height will be 5. Right? That is at the beginning. Let's see if this equation gives us what we expect. Let's put 5. T equals 5 here. Sorry, let's put t equals 0 here. Because at the beginning, the time is 0. Thank you. Okay. So we have 25 sine pi over 2 into 0 minus 1 plus 30. Now, pi over 2 times minus 1 is minus pi over 2. So we get 25 sine minus pi over 2 plus 30. Now what's sine minus pi over 2? Sine minus pi over 2, as you know, from the unit circle, this is plus pi over 2. This is minus pi over 2. Because if you're going this way, it is negative. If you're going this way, it is positive. The angle is positive. Here it is plus 1, here it is minus 1. So the sine of minus pi over 2, sine minus pi over 2 is minus 1. Okay, so that's minus 1. We get here minus 1. This becomes minus 1. So 25 times minus 1 is minus 25. Plus 30 equals 5. There you have it. So as we expected, it's 5 meter. Let's do another checking. When h is 1, time is 1, we expect h to be 30. Let's see. Okay, let's substitute. T is 1. So 1 minus 1 is 0. So sine pi over 2 times 0 is 0. What is sine 0? 0. Okay, as you know, at this point, sine 0 is 0. It's the y coordinate, which is 0. Okay, so this means the whole thing here goes, because you're multiplying by 0. So you are left with 30. So the answer is 30 meters. And that's what you expected. Okay, and the same story is done similarly when you have h equals 2, and h equals 3, and h 4. I leave this for you as an exercise to satisfy yourself, and I am sure you're going to get the right answers. That is h2 55. Okay. Yeah. And h3 will be back to 30, and h4 will be back to 5. And there you have it, folks. I hope you enjoyed it, and please like and subscribe, and see you in the next video. Thank you.